The first step in analyzing a statically determinate beam or in drawing the shear and moment diagrams is to determine the reactions. And after drawing the shear and moment diagrams, you will know if the value of the reaction is wrong, if the value of the moment at the last point, like in this case, point E, if the moment at A is not equal to 0 or simply dili mag-close ang moment diagram. So in this video, I'm going to show you how to determine the reactions of a statically determinate beam. And at the same time, I'm going to introduce a shortcut, a calculator technique wherein you can determine the reactions easily. Okay, let us start. So at A, this is a hinge support. So there are two reaction components. This one, vertical, AY, and horizontal. Let's assume na directed to the right, AX. While at E, this is a roller support. So we only have one reaction component, which is vertical, EY. But by inspection, since there are no other horizontal force, so therefore AX is equal to 0. Okay. So next is we sum up force along the vertical or Y. And sign convention is upward forces are positive. So we have AY, A sub Y plus E sub Y. And then this is downward. So minus 20, minus 40, and minus 60 equal to 0. So next is i-transpose ne. We have AY plus EY equals transpose all the constants to the right side. So we have 20 plus 40 plus 60. And we have AY. Finally, we have AY plus EY equals 120. This is our equation 1. And the next condition is summation of moment. You can sum up moment at about A or E. But for Caltech purposes, let's sum up moment about the left support A equal to 0. Our sign convention is counterclockwise moment positive. So since we will sum up moment about A, AY has no moment since the distance is 0. But for Caltech purposes, we will include AY. Okay? So we will include AY, but then the distance is 0. This is for Caltech purposes later. Caltech purposes lang. And then EY, counterclockwise, so positive, plus EY. The distance of EY to point A is 8. 8. And then minus 20. The distance of 20 from A is 2. Minus 40. The distance of 40 from A is 4. And then minus 60. The distance is 6. Equal to 0. Okay. And then we will transpose all the constants to the right. So we have AY 0 plus EY times 8 equals 20 times 2 plus 40 times 4 plus 3 times 6. And finally, we have AY times 0 plus EY times 8. 20 times 2 plus 40 times 4 plus 60 times 6. 560. And since AY is 0, we can solve for EY. EY is 560 over 8, no? Divided by 8. And 70 kilo newtons upward. And we go back to equation 1. From 1, we can solve for AY. So we have AY plus EY. EY is 70 equals 120. So AY equals 50. Okay. This is the conventional way of determining the reactions. Now, we will use Caltech. And by using Caltech, we don't need to write this one. And this is very useful if you will be taking the board exam or if the exam is online and the solution is not needed. Okay. So, sa Caltech, we'll use mode equations. So, mode equations, two unknowns, okay? Two unknowns. So, ano siya? The first unknown is AY, our X, AX, AY, and then this is X, first variable, second variable, and then constants. Now, our first line is summation of force sa X. And then our second line is summation of moment. So what we will do is, we will put here coefficients. So, equation 1 is 1, 1, and then 120. 120. Pero, what you will do is sa screen, you will input 20 plus 40 plus 60. Like in this one. Okay, so I am using Canon. So, mode, equation, 5, and two unknowns, 1. Okay, so I'm going to input 1, coefficient of AX, 1, coefficient of is it AY, EY, and then sa constant, I'm going to put 20 plus 40 plus 60. Pero ang mo appear sa C is 120. Okay. 120. Okay. Now, sa summation of moment, that is why we have to include AY for Caltech purposes. So, the coefficient of AY is 0. And then coefficient of EY is 8. And then 560. Pero, what we're going to input is this one. 20 times 2 plus 40 times 4 plus 60 times 6. 560. So we have 0, 8, and 560. And then we have this one as well. X, this is our AY, 50. and then equals 70 EY. So it's that simple, no? If you will use Caltech. So the technique or the shortcut is this one. Okay. This is applicable for two supports, hinge and roller. Not applicable for, this is not the format for um cantilever, but for simple supported or if there's an overhang, pwede lang. So the coefficients are, for the first line, we have 1, 1, and then constant. The constant is this. All forces, if the force is downward, positive siya. Why positive? Because originally, in the equation, if the force is downward, negative. But remember, all these values, i-transpose sa right side. So, ma-change ang sign. That's the reason na ma-positive siya. So, kung downward, originally negative, becomes positive. Kaya i-transpose man. Oh, so positive. So, kung upward ang force, originally positive kay upward, pero i-transpose, ma-negative siya. Ma-negative siya sa C. Similarly, sa moment, our sign convention is counterclockwise positive. So if clockwise movement, originally negative, pero knowing na i-transpose siya sa right side, it becomes positive. Therefore, all clockwise movements considered as positive sa Caltech, no? Oh, knowing na originally negative siya kay clockwise, but then i-transpose man, so it becomes, or the sign becomes positive. Oh, so kana alang, no? That's very important para dili ma um, dili ma-incorrect ang sign sa right side. And then sa second line, 0, and then this one, this is the distance between the supports. The distance from A to E is 8. So this is very easy. For the first line, we have 1, 1. The second line is 0, and then distance between supports. And then sa constant, I have explained already. Now for this one, force, downward positive since it transpose, and then pag clockwise positive also since originally negative, and then it transpose positive. Okay. So with that, let us try to solve other problems, no, using Caltech na, not conventional na solution. Okay. So for this one, this one is again 0. Okay. So let's use Caltech na. Okay. Now, okay. So again, the first line is 1, 1, and we have a downward of 900. So downward, originally negative, that becomes positive. And then the uniform load, uniformly distributed load, we have the resultant of area, no? 120 times 120 times 12. So 120 times 12. No need to solve for the resultant. You just put plus 120 times 12. That's it. So, equals. For the second line, 0. Distance between support, 12. Okay. Moment, say it. We sum up moment about A, no? So 900 is clockwise. So positive. 900. Force, the distance is 8. So times 8. Okay, plus. Okay. 120 times 12. 120 times 12, force lang, times distance. And since this is a uniformly distributed load, the resultant acts at the centroid, or 1/2 of 12. So this distance is 6. So we'll multiply the resultant by 6. So 120 times 12, force times distance 6. Okay. And the reaction is 1020, and y is 1320. Okay. That's it. That's very simple. No? Okay. Next. AY 0, and then BY. Now, sige. 1, 1. Okay. This one is moment. So, sa first line kay force match, this will not be included. So, we only have this one. And the resultant is 10 times distance, 5. Okay, so we put 10 times 5. Okay. For the second line, 0 and distance between support. 5 also. 1 plus 1 plus 3, 5. Okay. For the moment, now, this one, the distance is, this distance is 1/2 of 5. The length is 5. 5, so therefore, this is 2.5 plus 2. So the distance of this force to A is 4.5. So we have 10 times 5 times 4.5. Okay. And then this is moment. So pag moment na, no distance na. 25. But then, counterclockwise man. So minus. Kaya counter man. Originally positive, pero pag i-transpose becomes negative. So we have to subtract 25. No distance na kay moment. That's it. And, okay. AY is 10 and DY is 40. That's it, no? Okay, another one. Okay. So we have this one, BY, BX 0, and then EY. Okay. Default 1, 1, force. 60 downward, so positive 60. And then this one, downward na. The resultant is 40 times 3. Okay, plus 40 times 3. That's it. This is moment now. So not included. Okay. Second line, 0. Distance between support. 5. No? 3, 1, 1. So 5. Okay. Now, let us start with 60. The moment of 60 about B is counterclockwise. Originally, positive, pero pag transpose becomes negative. So that's negative 60 times distance. The distance of 60 to A is 1. For this one, the moment is clockwise. So, positive na. Originally negative. transpose positive. So plus 40 times 3 distance. What's the distance of this one? It's 1.5. Okay, 3 man. And then as centroid. So it's 1.5. So times 1.5. And then this one, 120 clockwise. So that becomes positive. Okay. So our x is 132. By is 132. And ay is 48. And the last one is this. You have one. Okay. Force. You have 100 plus this one. Resultant. 120 times 2. Okay. So we have 120 times 2 plus this one. 120 times 2 also plus 120 times 2. Okay. For the second line, 0 and then distance between support A to C, that's 4. Okay, moment. Sa left support man, no? So, we start with 120. The moment of 120 times 2 is clockwise. So, that's positive. So, 120 times 2, the distance is 1. Plus, the moment of 100 is clockwise man, so positive. The distance of 100 to A is 2. And then last this one, 120 times 2. The distance of 120 to A is 5. Okay, 1 mani. 1 plus 2 plus 2, you have 5. Equals. And our x, AY, is 170 and CY is 410. Okay, that's it. So that's how we use Caltech in determining the reactions of statically determinate beams. So I hope that you have learned something from this video that you can use in analyzing statically determinate beams. And remember that the value of the reaction is very important. So that your diagram will close or the value of the moment sa rightmost point becomes 0. So, thank you for watching.